dear students, this is Mrs. Shaima Gharib and today's lesson about probability. In this video, we are going to talk about how can we write probability using words and how we can write the probability using numbers. Are you ready? Let's revise some rules before you watch any video. First, you have to sit in a quiet place. You should have your pen and a piece of paper to take notes and to solve the questions. You should pause the video after each question, then you try to answer on your own. Then you play the video to check your answer and to understand the question in case you get a wrong answer. Are you ready? Let's start. Probability is the chance of an event to occur, or we can say it is how likely something is to happen. Probability is same meaning as the likelihood or the chance. So we can say probability, we can say likelihood, we can say chance. Probability of an event could be impossible, unlikely, or poor chance. Both have the same meaning. Equally likely or even a chance, likely or good chance, both have the same meaning, or certain. Now, let's talk about mutually exclusive events. What are the mutually exclusive events? They are events that don't occur at the same time. For example, when a coin is tossed, then the result will be either head or tail. But we cannot get both the results, which means two events that cannot happen at the same time. So mutually exclusive events in the coin, when we toss a coin, we have only two possibilities, head or tail. Can we get both of them at the same time? No. That's why we call them mutually exclusive events. Is this clear? It's really important to know the meaning of mutually exclusive events. Now, let's talk about how we can write probability. We can write the probability using words as no chance or poor chance, even chance, good chance, and certain. So the probability here is moving from the least to the highest. We can also say impossible, which is equal to no chance. Both have the same meaning. And poor chance is equal to unlikely. Even chance is same as equally likely. Good chance is same as likely, and certain is certain as it is. So we have two ways to write probability in words. We can use these words up or these words down. It's really important to know these words and try to write it by your own. And remember, they are moving from the least to happen to the most certain to happen. Is this clear? We can also write the probability using numbers. Let's see. If I want to write an impossible action as a number, it will be number 0 because it will never happen. The probability here is 0. It's impossible. What about equally chance or equally likely or even a chance? The probability then will be 1 over 2, which is half. We can say half, 1 over 2, or 50% or 0.5. The certain action means the probability equals to 1, or we can say 100%. Is this clear? What about the unlikely and likely actions? The unlikely actions has probability that less than half or less than 0.5 or less than 50%. The likely actions has a probability that is more than half or more than 0.5 or more than 50%. Is this clear now? How do we write probability in words in two ways? Up here and down, and in numbers. Let's see. Probability using words. Let's see this example. Nada puts 9 green balls and 3 blue balls into a bag. As you can see, 9 green and 3 blue. She takes out 1 ball at random. What is the likelihood of getting a green ball? What do you think? Which word can express the probability of picking a green ball here? Is it a good chance to get a green, or a poor chance, or impossible, or certain? Which of these words can express the probability here? As long as we have more green balls than blue balls, so the probability of getting a green ball will be likely. Is this clear? Now, what is the probability of getting a red ball? Do we have any red ball here? Which means this is an impossible action. And we said, you remember, impossible action can be written in numbers as number 0. So we are going to write impossible. What is the probability of getting a ball? No colors are mentioned here. So all the balls are in, which means it's a certain action. So the probability here will be certain. And we said before, if I want to write a certain action in numbers, it will be number 1. What is the probability of getting a blue ball? What do you think? There is 3 balls, blue balls, which means it has a probability that is less than the green. The chance here is less than the chance of the green, which means it's unlikely chance or poor chance. What is the probability of getting a blue or a green ball? In this question, he's asking about both colors, blue or green, which means all the balls here, because all the balls are green and blue only. Then the probability here will be certain. It's 100% blue or green. Is this clear? Now, let's talk about probability using numbers. In order to write the probability in numbers, it's preferred to be written as a fraction. So let's see how do we write. Up, we are going to write the number of the desired outcomes over the total number of outcomes. Now, let's see what the meaning of desired outcomes and total number of outcomes. So in this example, it's the same example as before. So it has in total how many balls are there in total, which means the total number of outcomes. So the total number of outcomes means how many balls are here. They are 12. So the probability in this example will be always a fraction over 12, whatever the question is. So if the question asked you about anything, it must be always over 12. Now, what about the desired outcomes? Let's see the question. What is the probability of getting a green ball? So he's asking you about the green balls only, which means this is the desired outcome. So the desired outcome is what the question asks you about. So the number of green balls is the number of the desired outcomes, which is number 9, because there are 9 green balls. So how do we write the probability here as a fraction? We said the number of desired over the total number of outcomes. So the number of desired outcomes, which is the green balls, is number 9, and the total number of outcomes is 12. So the probability then will be 9 over 12. We can write it in the simplest form. Is this clear? Let's see the next question. What is the probability of getting a red ball? So this is the desired outcome, the red ball. How many red balls do you have here? Nothing, 0. So I'm going to write it as 0 over the total number of outcomes, which is number 12. Let's see if I write it as 0 over 12. Can I write the impossible action as a fraction 0 over 12? No, it's preferred to be written as just 0. Do you remember? We said before, when I have an impossible event, I write the probability as 0. Don't write it 0 over 12, okay? It's correct, but it's preferred to be written as 0. Is this clear? Now let's go to the next question. What is the probability of getting a ball? So no color here. So how many balls do we have in total? 12 over the total number of outcomes, which is 12. So it will be 12 over 12. Or we can write it as 1 because this is a certain action. Do you remember how to write certain actions in numbers? So it's preferred to be written as number 1. 12 over 12 is correct, but this is the best answer. What is the probability of getting a blue ball? So the desired outcome is the number of blue balls. How many blue balls we have? 3. And the total number of outcomes, we said it will be always 12. So the answer will be 3 over 12. We can put it in the simplest form as 1 over 4. Is this clear? Let's erase this and see the next question. Okay. The next question, what is the probability of getting a blue or a green ball? What do you think? Blue or green, which means both of them together, which means it is a certain action. And we said we write certain actions as number 1. So the answer here will be number 1 because it is a certain action, which is 12 because green and blue together are 12. So it will be 12 over 12, which is 1. Is this clear? Look at the example here. Dina has a spinner with 8 numbers, as you can see. What is the probability of spinning a 5? We said in order to write the probability, we are going to write it as a fraction. The number up will be the number of desired outcomes. The number of desired outcomes is what mentioned in the question, which is spinning a 5. So how many 5s are there in this spinner? There are 2 5s, 1, 2. So this is the number of desired outcomes. And we said it should be over the total number of outcomes. For this spinner, the total number of outcomes is number. How many outcomes are there in total? All of them together are 8 outcomes. Is this clear? Which means the fraction here, we said there are 2 5s and the total number of outcomes is 8. So the fraction will be 2 over 8. And this will be our probability. Now, next question. What is the probability of spinning an even number? So this is the desired outcomes. Let's count how many even numbers are there. 1, 2, 3. So it will be 3 over, what did we say? The total number of outcomes, which is 8, and it will be always 8 in all questions. It will never change. So the probability of spinning an even number, we said there are 3 even numbers. So it will be, yes, 3 over 8. What about the next question? What is the probability of spinning an odd number? So this is the desired outcome. Let's count on how many odd numbers are there. We have 1, 2, 3, 4, and 5. So there are 5 odd numbers. Then the probability will be 5 over, yes, 8. Is this clear? Let's see next question. What is the probability of spinning a number less than 5? Let's see how many numbers here are less than 5. We have number 1, 4 here, and one more. So 2, 3, 4, 5, and 6. So we have 6 numbers that less than 5. So there are 6 numbers less than 5. Then the probability will be 6 over 8. Next question. What is the probability of spinning a number less than 6? What do you think? All the numbers here are less than 6, which means it is a certain action. Then the probability will be number 1, or we said all of them over the total number, which is 8 over 8, which is number 1. Is this clear? What is the probability of spinning a number more than 5? Do we have any number on this spinner that more than 5? No, which means it is an impossible action. So the number will be 0. And we said don't write 0 over 8 or 0 over any number. Is this clear? Now, look at this question. It's really important question. Which two numbers have the same chance of appearance? What does this mean? When two numbers have the same chance of appearance, it means they both have the same number of chances. So which two numbers here are repeated for the same number of times? What do you think? Let me erase so you can see more clear. What do you think now? Which two numbers have the same chance of appearance? Look at number 4. It is repeated 3 times, right? And number 1 is repeated 3 times. So both of them have the same chance of appearance. So the two numbers are 1 and 4. Is this clear? Now, let's talk about the probability of a coin. When we have a coin, we know that it has 2 faces, either to be head or tail. Is this clear? So if I asked you about what is the probability of tossing a head, what do you think? What is the total number of outcomes for a coin? The total number of outcomes, we said we only have head or tail, nothing more. So it has a total of 2. So any question will be a fraction over 2. Now, what is the probability of tossing a head? So this is the desired outcome. How many heads are there in the coin? Only 1. Then the probability of tossing a head will be 1 over 2. Okay, let's try another question. What is the probability of tossing a tail? What do you think? How many tails are there in the coin? Only one. So the probability will be 1 over 2 because we said the total number of outcomes for any coin is always 2. So the probability then will be half as well, or equally likely, or even a chance if the question asked you to write it in words. Is this clear? What is the mutually exclusive event for tossing a head? What do you think? What do you remember the meaning of mutually exclusive event? We said before, they are events that cannot happen at the same time. So if you are tossing a head, which event cannot happen at the same time? What do you think? Of course, tossing a tail, because you cannot toss a coin and you get head and tail at the same time. So the mutually exclusive event for tossing a head is tossing a tail. Is this clear? Now, let's talk about probability of a six-sided dice. All of you know how the dice looks like. It has 6 faces numbered from 1 to 6. Now, the total number of outcomes for any die or for the dice is 6 because it has 6 outcomes. It could be 1 or 2 or 3 or 4 or 5 or 6. So the total number of outcomes for the dice is number 6. Now, let's see the question. What is the probability of getting a number 5? So how many 5s are there in the dice? Only 1. So the probability then will be 1 over 6. What about the probability of getting number 3? How many 3s in the dice? Only 1. Then the probability will be 1 over 6 as well, because there is only 1 3 and the total number of outcomes is 6. We said all the questions will be fractions over 6 because this is the total number of outcomes. The desired outcome over the total number of outcomes. Let's see next question. What is the probability of getting number 8? Do we have number 8 in the dice? No, which means it's impossible, which means it's number 0. What is the probability of getting a number less than 7? All the numbers in the dice are less than 7, which means it's a certain action, then the probability will be 6 over 6, which is 1. Is this clear? Here it is. Next question, what is the probability of getting an even number? What are the even numbers in the dice that you know? It has number 2 and number 4 and number 6. So how many even numbers are there in the dice? There are 3 numbers, 2 and 4 and 6. Then the probability will be 3 over 6. We can write it in the simplest form as half, and which equal to equally likely event or even a chance event. Is this clear? What is the probability of getting an odd number? Let's find out how many odd numbers are there in the dice. We have number 1, we have number 3, and we have number 5. So how many numbers are they? 3. So it will be 3 over 6. It can be written as half or as even a chance or equally likely if it is in words. Is this clear? Now look at this question. What is the probability of getting a number more than 4? What are the numbers that more than 4 in the dice? We have only number 5 and number 6. So they are 2 numbers only. Then the probability will be written as 2 over 6. Is this clear now? Now let's see our questions. Are you ready? Let's start. A fair 1 to 6 dice is thrown. Draw a line to match the event with the mutually exclusive event. We have two events here. We are going to match each event with the mutually exclusive event. Let's start by the first event here. Even number is thrown. What do you think? What is the mutually exclusive event for this event? Let's check one by one. 2 is thrown. 2 is an even number, so it's not mutually exclusive. Do you remember what the meaning of mutually exclusive events? They are events that cannot happen at the same time. So this will not be our answer. 2 or 3 is thrown. 2 is an even number. 3 is not. So part of this event could happen and the other part cannot happen. So this is also not a mutually exclusive event. So it must be impossible to happen at all. Is this clear? What about this one? 3 is thrown. Is 3 an even number? No, so this will be the mutually exclusive event for even number if an even number is thrown. So these two cannot happen at the same time. Is this clear? What about 3 or 4? 3 is mutually exclusive, but 4 is not, so all of it is not. 2, 4, or 6? All of them are even, so it's not a mutually exclusive event. Now we'll go to the next event, which is odd number is thrown. What do you think? Odd number is thrown. Is 2 an odd number? No. Could these two events happen at the same time? No. So this will be a mutually exclusive event for odd number is thrown. What about 2 or 3? Part of it, okay, and the other part is not. So all of it is not. 3 is thrown. It's an odd number, so it's not a mutually exclusive. 3 or 4? The 3 is odd and the 4 is even, so not all the event is mutually exclusive, so it's not mutually exclusive. What about this one? 2 or 4 or 6 is thrown. So if 2 or 4 or 6, is this an odd number? Any of them is odd number? No. So these two events are mutually exclusive events. Is this clear now? The mutually exclusive events. Let's see next question. Here are 4 bags containing black and white beads. As you can see, bag A, B, C, and D. Complete the following sentences. Let's see. The best chance of picking a black bead is from which bag? What do you think? Let's see. First, in order to answer this question, to know the best chance here means the biggest fraction, the biggest probability, the biggest chance. So let's find the probability of picking a black bead from each bag. For the first bag, we have 4 black beads over 7 beads in total. So the probability of black beads will be 4 over 7. What about the second bag? How many black here? 5 over total of 7. So it will be 5 over 7. What about bag C? There are 8 black over, yes, 14 in total. So it will be 8 over 14. What about bag D? There are 5 black over 8 in total, so it will be 5 over 8. Now, we need to know which fraction of these fractions is the biggest one. What do you think? If I have 4 over 7, 5 over 7, and this is 8 over 14, can I write this as a fraction over 7? Do you remember? Equivalent fractions, we can write this one as, if I divide it up and down by 2, it will be 4 over 7, right? So far, which fraction is the biggest? I have 4 over 7, 5 over 7, and 4 over 7. So far, this one is the biggest. So what about, which is the biggest? 5 over 7 or 5 over 8? What do you think? Which one is the biggest? If you have 5 and you're going to share it among 7, or if you have 5 and you're going to share it among 8. So the biggest one is 5 over 7. So which means from bag B. So the best chance or the biggest chance, we said it means the biggest probability or the biggest fraction will be from bag B. Let's see next question. The probability of picking a black bead is the same from bag what as from bag what? I think we already answered this question because 4 over 7 is same as 8 over 14. They both equal to each other. These two are equal to each other. So we can say that the two bags that have the same probability of picking a black bead are bags A and C. Is this clear now? Let's see the last question. It's a bit advanced than the other fractions, so I want you to pay attention to this question. Aaron rolled 2 number cubes at the same time, 2 dice. All the examples about the dice we took before, they have only 1 dice. But here, if we play with 2 dice at the same time, what is the probability of getting 2 sixes? First, we said we have to find the total number of outcomes. If I have 1 dice, then the total number of outcomes will be number 6. But what if I have 2 dice? Can you think? If you have the 2 dice, we can play with them and find out the total outcomes. Let's think together. If I have dice 1 and dice 2, I can get 1 and 1 on both dice, or 1 and 2, or 1 and 3, or 1, 4, or 1, 5, or 1, 6. So far I have 6 possible outcomes. Or I can get 2 on die number 1 with 1 on die number 2, or 2, 2, or 2, 3, 2, 4, 2, 5, or 2, 6. So we have 6 more possibilities. Or I can also get 3 on die 1 with 1 on die 2, or 3, 2, or 3, 3, or 3, 4, or 3, 5, or 3, 6. Or I can get 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Or 5, 1, 5, 2, exactly the same until I reach 6, 1 up to 6, 6 here. So now I have all the possible outcomes when I play with 2 dice. What do you think? The total number of outcomes when I have 2 dice, 2 6-sided dice, will be number, this is 6 outcomes, and 6 and 6 and 6 and 6 and 6. So it is 36 possible outcomes. So any probability I'm going to write will be over 36. Now let's see the first question. What is the probability of getting two sixes, which means 6 and 6? How many 6 and 6 are there? Here it is, only one. So it will be 1 over 36. What is the probability of getting two even numbers? Let's see, two even numbers. This is no. All of them are odd, so let's look at this dice here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 possibilities to get two even numbers, which is 9 over 36. We can also write it in the simplest form. If we divide it up and down by 9, we'll get 1 over 4. Is this clear? Now let's answer the last question. What is the probability of getting at least one odd number? At least one odd number. So I have here 6 possibilities. At least one odd. 1, 2, 3. And here I have 3 possible outcomes. And here 1, 2, 3, 4, 5, 6. All of them. 6 possible outcomes. And here 1, 2, 3, 3 possible outcomes. And here we have all of them 6 possible outcomes. And here 1, 2, 3, 3 possible outcomes. So the total number of the desired outcomes here, 6 plus 3 plus 6 plus 3 plus 6 plus 3, which is number 27. So it will be 27 over 36. Or we can simplify it by dividing up and down by 9. So it will be 3 over 4. This is the end of our lesson today. I hope you enjoyed the video, and if you have any question, please feel free to leave a comment and I will answer you as soon as possible. See you next video, and please remember that your feedback is highly appreciated. Thank you very much and see you soon.